Good morning students, welcome to Sri Guru online classes. Today I am going to discuss second year in the second part, chapter number 11, that is dual nature of matter and radiation. Dual nature of matter and radiations. In this chapter, we are discussing the emission of electron. Why we are discussing the emission of electron means that emitted electrons will give us, those electrons motions will give us a current, conduction. The motion of electrons gives us a conductions. And this is lecture number 1. Particularly in this lecture, I am going to discuss the very important and very basic things, that is radiation and matters behaves like a wave as well as material natures. Already we know that light moves in a straight path and it forms the images, and also light is a wave nature and as well as particle nature. This particle natures was explained by de Broglie. We will discuss the de Broglie hypothesis and de Broglie concept in later classes. In this today class, why we are calling radiations and matter having dual natures. We have studied the two aspects in that, wave optics as well as ray optics. The first one is light which travels in a straight line, it forms the images. Another aspect, the wave nature of light, we discussed in the interference, diffraction and polarizations, as well as in the superposition principles. But here, according to Einstein's, the light carries all the nature of materials, means light means radiations. Radiation carries all the nature of materials, and materials also carries all the nature of radiations. Material also carries all the nature of radiations. These things we'll discuss in detail in the today lecture. So far we have studied the light is a form of energy. That energy is sufficient to removal of electron from the surface of a metal. Any type of metals, you can consider zinc metals, cobalt, nickel, any type of metals you consider. On that particular metal surface, the freely moving electrons, or just to consider atom which consists of a positively charged nucleus, and in that atoms the electrons are revolving around the nucleus. In the outermost orbit, the electrons are loosely bound. Those electrons will come out from that orbit. For those electrons, we are giving a sufficient energy to escape from that orbit. Those electrons will hit another surface, a positively charged surface. In that positively charged surface, the electrons will again move from that surface to another surface. This type of motion of electrons we call as random motion of electrons in a metallic surface, any type of metallic surface. This random motion of electrons will give us a conduction, any type of electric current or current flowing through that particular metallic surface, or we are seeing in a particular device a small variation of current. By giving a sufficient energy to that electron, that electrons will come out from that particular surface. And here two different aspects are there. One is how this radiation is behaves like a matter, and matter is behaves like a radiation. So we know that radiations we can't see, and we can't measure its volume or we can't measure its mass. We can sense the radiations, but matter or material we can sense, as well as we can measure the volume and as we can measure the mass. This is the major difference of radiation and matter. Any kind of radiations. And matter means like a materials, any type of materials. Here we know that radiation means it spreads in the form of waves. Matter means like a bullet, it shoots in a straight line. Like a bullet, it moves in a straight path. Radiation means spreads in waveforms, spreads in a waves. And this matter means or we can call straight line, or like a bullet, it shoots in a straight line and it has no mass. We know already it has no mass, it has mass. And third one is very important. It spreads in a wave, it moves in a straight line, or it hits like a bullet, and it has no mass. We know that already. Light does not have any mass. We can convert in terms of frequency and we are finding the energy. But here is, we can say that a radiation in the form of energy, matter is also in the form of energy. We are saying that radiation energy means in the form of frequency. By using frequency we are going to find this radiation energy. And here is, it has also energy, it has also energy. But here matter means particular mass, momentum, and we are finding the kinetic energy. But very important, the representation of or representative of radiation is light. We are representing radiation in terms of light. We are discussing radiation in the form of light, and representative of material in the universe, smallest representation of matter is we know that is electron. Smallest, and this is the representative of radiation, and this is the representation of matter. And light obeys all the properties of matter, which follows the properties of matter, and electrons is also follows the matter of radiations. And this was explained by Einstein and Planck. Einstein explains dual nature of radiation and matter. Light got all the nature of matter, and electron got all the nature of radiations. This was explained by Einstein. And after the Einstein, many scientists are discovered or observed the dual nature of matters. But they discuss the wave nature as well as material nature, but this matter is also a dual nature was discovered by de Broglie. That is the de Broglie hypothesis, and de Broglie concept is very important, and de Broglie proves that the matter is also a dual nature, and experimentally proved that matter is also obeys all the properties of radiation. Hence the conclusion of our bit is both radiation and matter having dual nature. It behaves like a radiation and this is also behaves like a matter. Only one difference is we can sense the radiations. We can't see. It is not visible. We can sense the radiation, but this is visible, and we can see in the form of volume also. We can measure this material in terms of volume. Any type of material, we suppose we considering a metallic surface, means metal having a certain volume. In that metals there is a number of electrons and there is a number of protons. We can see in the form of volumes, but radiations we can sense only, but we can find all the properties in the electron also. Light is also got all the properties of materials. This is why the final conclusion of Einstein and Planck's are radiations, matters are dual nature. Both are dual natures. Radiations and matters having dual nature, but they do not have different quantities or different things. But they behave like a radiations, dual nature, both having a dual nature. This is the basic discussion of radiation and matter. In this chapter, the very important is the electron emission. Why we are discussing that electron emission means the electrons from the any surface. Let us consider a metallic surface. That electrons gets a sufficient energy. Giving the energy to that metallic surface is, one is in the form of frequency, another is intensity. If we increase the intensity, when a light of suitable frequency or when a light of suitable intensity, as intensity increases, the current flowing in particular medium is also increases. If it also increases, the current is also increases. But major difference is intensity. We can increase the intensity by increasing the, for example, 100 watt, 200 watt, 200 watt, 300 watt. Like this, we are increasing the intensity of light without changing the color. Same. Color must be same. Either you take yellow color or any type of color, the color must be same. But come to the frequency means, if color change its color or color change. For example, 100 watt bulb we are using with the different colors, blue, yellow, green, red. If the color changes, frequency is going to change. If the watt goes on increases, intensity is also increases. And sometimes we need a particular specific incident light. On that particular specific incident light, we should use the frequency is constant but variation of intensity. If the variation of intensity, if the frequency is constant, means color is remains same. Color remains means yellow color. Variation of intensity means 100 watt, 200 watt, 300 watt. Like this we are increasing the intensity but frequencies remains same. Intensity increases, frequencies remain same. But in the some aspects we are seeing that frequencies remain same. Frequencies increases, intensities remain same. 100 watt, okay, then 100 watt red color, 100 watt yellow color, 100 watt blue color. We change the color of light but intensity remains fixed. Intensity of light remains fixed. Intensity is fixed. Variation of frequency by changing the colors. Like this we are giving the energy of any type of metallic surface. Just you considering this is a photosensitive substance. When a light of suitable frequency is incidenting on this particular suitable frequency of light or suitable intensity of light, here is many electrons are there. These electrons are freely bound electrons. When light of suitable intensity is incidenting on this particular electrons, this will come out from that surface by variation of frequency and intensity. This is the basic explanation of how that electrons are going to emit from that particular surface. Let us discuss one by one by emission of electrons. In that emission of electrons are also the many types, and that very important is photoelectric emissions. We are discussing the types of emission. We will discuss those things in details. As sufficient energy. If that electrons get sufficient energy, means definitely that electrons will come out from that surface. That come out from the surface. That energy given to that electron we call as a work function. That energy given to the electron is called as work function. That may be any type of energy. Any type of energy we will discuss detail. Okay, before going to explain that work function, what electron emission? What is mean by electron emission? It is the one of the process. It is one of the process. The removal of electron from the any surface or any substance. Just you consider it as a metallic surface. It is the process in which the emission of electron from the substance or any type of metals. Why we are considering metals only? It is having a conducting properties. The conduction occurs. That's why I am considering the metals. Electron emission. Electron emission means the process of emission of electron from the metallic substance or any type of substance. See here, just to considering this is atom, positively charged, that is protons, the center of nucleus, and here is the electrons are revolving around the nucleus, and on this outermost orbit these electrons are loosely bound electrons. If suppose these electrons will come out from that surface, let us consider these electrons bounce back somewhere here. somewhere here. Again it will come back to and hit the another atom. It is more number of positive electrons or positively charged atom. If this electrons hits here, definitely it is going to balance, and here the balanced electrons will come out. This is the process which occurs in a metallic surface, and this electrons does not come out from this surface without giving any energy. This continuous process are in that particular metallic surface. We know that already. Charge of metal is 0. Why? Because the net charge on this metallic surface is 0. Why? Because as number of positive charge and as number of negative charge are equal. We already discussed these things in first bit, electrostatics. Charge are conserved. In this chapter we are going to give a sufficient energy to this electron, and this electron will escape from this metallic substance. If suppose this electrons will come out from this substance, means this is negatively charged, and definitely here is a positively charged, and this force of attractions, this we considering as a potential energy. This potential energy, we know that already. The force of attraction is inversely proportional. Force of attraction is inversely proportional. As less distance, the force of attraction is. If suppose it is going to more, the force of attraction is also more, and this we called as potential barrier. If this potential barriers cross that electrons, this barrier, the bombardment of electrons or the liberation of electron from this metallic surface, these electrons will come out from the surface, or this barrier, cross that barriers, means definitely that electrons gains a sufficient energy to escape from this metallic surface. Escape from this metallic surface. How it is going to escape from the metallic surface? If suppose it gains a sufficient energy, then only these electrons will come out from this surface. Otherwise it is not possible to escape from the metallic surface. Why? We know that already. Charge is conserved on any metallic surface, any conduction. Why? Because as number of protons as a number of electrons are equals, and loosely bound electrons are revolving around the nucleus. This type of process we call as electron emissions. This electron emission explains in the different types. Before going to explain that electron emission types, this energy we call as work function. That sufficient energy is given to that electron is called as work function. We know that already. This work is nothing but an energy. Already we discussed in the first year chapter that work is nothing but a energy. Some work function means minimum energy is given to the electron which is escape from that metallic surface. Minimum energy gained by an electron to escape from that metallic surface, that type of energy we call as work function. And this work function depends on the materials also, and it depends on the temperature, and depends on the nature of material also. Nature of materials, nature of substance, and it depends on temperature also. The work functions varies with the temperature also. If temperature changes, work function is also. If the temperature increases, the energy given to that electrons is also going to increase. It depends on temperature also and nature of material also. Nature of material also, and it depends on substance. Depends on substance. And the less work function is cesium atom, that is 2.14 electron volt, and highest work function is, that is 5.26 electron volt for platinum, and this is for cesium, and this is platinum. The work function is highest for platinum and work function for lowest for cesium, and this is the SI unit for work function. We already know that what is the unit of SI unit of energy or work. We know that is joule. We can also, another SI unit energy or work is electron volt. This is also one of the SI unit. Already you studied, this is in electrostatic chapter. What is work function? The work function is the minimum energy is given to the electron which is escaped from the metallic function. From that metallic surface, that electron escape that gains a sufficient energy, that we call as a work function. This work function is depends on temperature, nature of materials and substance, and the highest work function is the work function is highest for platinum, that is, this is 5.65 electron volt for platinum. This is highest work function, and this is lowest work function. For cesium materials or cesium substance, the work function is lowest. This is the minimum energy. This much of energy is given to the cesium metal surface. The electron easily escape from that cesium. And this much of energy is given to that platinum surface. Definitely, electron from the platinum surface is going to escape. This is the sufficient energy. You can say that this is the highest energy and this is the lowest energy among the metallic surface. Now come to the definition of electron volts. The electron volt is the amount of energy gained by an electron. It has been accelerated through a potential difference of 1 volt. What is electron volt? The electron volt is the amount of energy gained by an electron. It has been accelerated through a potential difference of 1 volt is called as electron volt. 1 electron volt, which is equal to 1.602 into 10 raised to minus 19 joule. 1 electron volt. We can also say that how we are going to define that electron volt means charge into potential difference. Charge into potential difference. Charge of an electron. 1 electron volt, we can say that. What is the definition of electron volt? Amount of energy gained by an electron. It has been accelerated through a potential difference of 1 volt. The energy in terms of charge in potential difference, that is PD, and this is charge of an electron is 1.602 into 10 raised to minus 19 coulomb, and the potential difference is 1 volts. Charge into volts, that we can also call as joule. 1 electron volt is equal to 1.602 into 10 raised to minus 19 joule. Charge into coulomb in terms of joule. Already we discussed these things in the first bit of the second year part. Okay, we got the definition of electron volts and also the value of 1 electron volt, that is 1.602 into 10 raised to minus 19 joule. This is the basic definition as well as the energy which is given to the electrons. We discussed in the form of work function, and this work function is depends on temperature, nature of material, substance, and this lowest work function for cesium metal and highest work function for platinum or platinum any surface which is going to escape the electron from that particular surface. This is the definition of electron emission and work function. Now I am going to explain the different types of emission of electrons. Those are very important, and the different types of emission of electrons will help us to explain the concept of emission of electron very easily. The types of emission of electrons. Many types are there. In that, these are the important types. The first one is Thermo-Ionic emission. What is meant by thermal emission or thermo-ionic emission? It is also one of the process in which the emission of electron when that metallic surface is heated. By heating that metallic surface, by heating those outermost orbit electrons, those electrons are loosely bound or revolving around that orbits, gains a sufficient energy by heating a metallic surface. This is our metallic surface, let us consider, and here is positively charged protons, and here is loosely bound electrons. We are heating this metallic surface, these electrons are bombarding, and these electrons, after getting sufficient energy, these electrons are escaped from that metallic surface. The highest temperature is around 2500 degrees Celsius. Up to that temperature, these electrons will not come out from that surface. We can say that thermo-ionic emission at a particular temperature, these electrons will come out, and this is also depends on substance and depends on temperature. As temperature increases, as number of electrons are in the outermost orbits, those are going to come out from that surface. This is called as thermo-ionic emission, and these are called as thermo-ions. These are called as thermo-ions, and you can see these thermo-ions in the cathode tubes. And also some of the light emitting tubes You can see, and this cathode tubes, they obeys the phenomena of thermo-ionic emission. And second one is field emission. Second one is field emission. Here we supplied a sufficient energy to electron to escape from that metallic surface. In this field emission, already we explained in the first part, and we have already studied that the electric field. Suppose this is our metallic surface, and this is positively charged nucleus, and here is our electrons in the outermost orbit, that is loosely bound electrons, and here the electric field is applied. This is the strongly positive charged plus Q, and this is negative charge. Here, due to this field, the emission of electrons takes place. Why? Because we know that the potential difference, which is equal to Q1 Q2 by a positively charged ions and negatively charged ions, these electrons get repelled by this negatively charged ions. This will come out from this surface. Why? Because force of repulsion takes place. This type of emission we call as field emission. We can say, or we can also say that this is called as cold cathode emission. This we can also say that. Cold cathode emission. We can observe this field emission in X-ray tubes. We can observe this field emission phenomena in X-ray tubes. X-ray also we are observing this field emission. This is one of the important emissions. And third one, the very important emission, that is photoelectric emission. Photoelectric means light of suitable frequencies incidentally on a metallic surface. That metallic surface, the outermost orbit or outermost surface loosely bound electrons gains a suitable frequency of energy. That kinetic energy goes on increases, the emission of electrons is also increases. Just to consider, this is our metallic surface, this is the positively charged, and here is our electrons. When light of suitable frequency is incidentally on the surface, and this sufficient energy or suitable frequency which help us to removal of these electrons, or these electrons gains sufficient energy through this light of suitable frequency, and these electrons will come out from that surface. And this is the very important. We will discuss in the further classes the photoelectric effect by Einstein's and Hornbach and Hertz, and we can also Maxwell's electromagnetic theory or we can also say that Heinrich Hertz observations, Allwatch observations on the basis of this photoelectric emission we'll discuss in the next class in details. This is the third type of emission, and last one is secondary emission. Secondary emission of electrons. It is also one of the process of emission. It is also one of the process of emission. Accelerating or bombardment of fast moving electron. Suppose we are considering this is the metallic surface. Here is positive charge, here is electrons. A fast moving electrons bombarding on this particular electrons. These electrons come out from that particular surface. Fast moving electrons bombarding on a particular metallic surface. That type of emission of electrons is called as secondary emission. Secondary emissions. And these are the very important types of emission of electrons. In that, we are going to discuss in detail photoelectric emissions. I think so. Got this concept. What are the types of emissions? Thermo-ionic emissions. Thermo-ionic emission means by heating a metallic surface, the removal of electron from that particular metallic surface. This is one of the external energy which is given to that electrons. If suppose we are not going to give that energy, definitely these electrons will not come out from the surface. By heating, these electrons will come out from that metallic surface. That process we call as thermo-ionic emission, and these are called as thermoions. We can see this thermoion concept in cathode tubes. The phenomena which obeys the cathode tubes, obeys the phenomena of thermoionic emissions. What is field emission means? It is also one of the process of emission of electrons. Applying a certain electric field near to that metallic surface. We know that already the force of repulsion and force of attraction concept. These negatively charged electrons will repel these electrons, and these electrons will come out from that metallic surface, and we can also call as fold cathode emissions. You can see this in the X-ray tubes. The phenomena of X-ray tubes obeys the field emissions. And come to the very important, and in this particular chapter we are discussing the major bit on this photoelectric emission only. What is this photoelectric emission means? The process of emission of electron. The process of emission of electron by supplying a sufficient frequency, sufficient suitable frequency to this outermost orbit electrons. These orbital electrons will come out from the metallic surface. Here is light is the light of suitable frequencies incidentally on this metallic surface. That suitable frequency helps to remove the electron from that metallic surface. And last one is secondary emissions. These emissions, we know that the bombardment of fast moving electrons when it takes place on any metallic surface, that is going to remove of electrons. These are the four important types of emission of electrons. And in the next class, we are going to explain in detail photoelectric emissions. Thank you.